Continuing the series of modern hard techno tutorials after the distorted kick drum using 909 samples, it's time to cover another fundamental element of a groovy beat, that is the drum break. Today we will add such a break to our project and compress it to create an even more dynamic sound, learn making chopped patterns and using a reverb in a totally new and creative way. If you are looking for more modern hard techno samples and serum presets, you can check out my sample packs website, where you will also find my hard/industrial techno sample and serum preset pack. As we could hear in either the intro of this tutorial or in the X-Ray track by Carve, drum breaks are an easy way to create more variety within the arrangement and percussion. If you want your break to sound more like the mentioned X-Ray track, which means you are looking for a dirty break sound, look for hip-hop drum breaks with the tempo of around 75 BPM. If you play such a break in Ableton with double speed, it's going to synchronize with the beat just fine. In my project, I used a much cleaner and processed sample from Dubstep sample pack. Both dubstep and techno genres share similar BPM range, so synchronizing this break will be easy as well. To alter the rhythm of the breaks and to play only the pieces we are interested in, we have to chop them. To do that, I load the samples in the drum rack. Without any adjustments, they will be out of sync with the beat. So to fix that, I will enable warping. The second break sounds fine, but the first one has to be sped up. Near the warp button, I click the half tempo button. And now both breaks are ready for further processing, though I will use only one of them. To chop the break in the sampler, I choose the slice mode. Blue vertical lines on the waveform show how the break will be sliced. We can tell the Ableton to chop the break by transients. And that's the best solution if you want to extract a single sound out of the break, so a single hi-hat or snare. The region setting cuts the break to as many slices as you choose with the regions option. We need rhythmic, easy to arrange patterns, so the best option for us is to slice the break by beat. This makes each slice's length equal to the value we set with the division control. I will pick 1/8 of the beat. Considering that this break is 2 bars long, I will end up with 16 slices. Let's chop up this break. Now I have a new channel with drum rack where each slice is in a separate pad and can be treated as an individual sound. I'm creating a new MIDI clip in that channel to write a pattern. If I would like to play the break as if I didn't chop it at all, I would have to write such a pattern. By placing slices in different order, I can create, for example, something like this. There are no rules here. You can repeat some of the slices or chop the break even further. Just create something you find cool. Let's process this break to make it more clicky and snappy. Usually we are interested in reducing the dynamic range to, for example, make a percussion group sound fuller. This is something you could see in my industrial techno percussion tutorial. Today we will do the exact opposite of that, so we will enlarge the dynamic range. But before that, let me introduce myself quickly and just say that if you wish to have other sound design or music production subjects explained in such an easy and practical way, consider going onto my website and learning more about my private music production lessons. Free consultations are available as well. Increasing the dynamic range will require a compressor. You can use the FabFilter Pro C or the Ableton's compressor. Both will be equally fine. On top, you can see the waveform of the uncompressed break. Our end goal is to make the waveform look and sound like this. Compared to the original one, we see lots of volume reduction, but only on certain parts of the break. The volume reduction will be realized by both threshold and ratio parameters. The threshold defines a volume level above which the compressor will start reducing the volume of the break. This volume reduction will be as large as the ratio value. To reduce the volume by a lot, we need the threshold to be low. And the ratio to be high. It can be even as high as infinity to 1, which means that the excess of volume will be as quiet as possible. If I set the threshold too high, then even despite high ratio, the volume reduction will be not large enough to achieve our aggressive sound. On the other hand, if the ratio is too small, then even a low threshold will not reduce the volume by much. Both threshold and ratio work together and their values depend on the input signal type and volume, the goal of compression and so on. The settings I'm showing you right now will apply best only in this particular scenario. We know how to reduce the volume of the sound, but if we compare that to the waveform we are after, we will notice that our compressor reduces the volume immediately once the volume is higher than the threshold. A parameter that can act as a fade-in for the compressor is the attack time, which currently is set to 1 millisecond. Once I increase it, the compressor starts to reduce the volume gradually. With a correct attack, that again depends on different factors, for example the drum breaks BPM or the threshold level, we will retain the peaks or transients in other words, and make only the latter part of each sound in the break quieter. With too large attacks though, the compressor will be always too late, given little to no volume reduction despite low threshold and high ratio. At last, the drum breaks compression can be screwed up by a wrong release time that tells for how long the volume reduction does last, once the volume of the input goes back below the threshold. If the release time is set to 0 or just a few milliseconds, the compression stops immediately, which is why the attack parameter we set earlier works well, preserving each peak in the signal. If we increase the release time, we will see that the volume reduction starts to affect the peaks. The compression is applied at all times, which is considered a bad thing. When that happens, the attack parameter becomes less and less useful. At last, I want to use the output control to compensate the difference in average volume of the break before and after compression. The next step is to add the reverb to make the break sound less dry. As always, I create a parallel processing chain for that. Among the few reverb plugins I have, I will use the Softtube TSA-R1R reverb that has a rich sound which will help fill in the sound. The reverb chain will be turned on and off by the automation, so I'm sure I won't hear the reverb whenever the kick drum is playing. Further reverb processing includes reducing its stereo width to make it take less space in the track. And equalization. I will high pass the reverb to make it lighter and sculpt the high end a bit. The dry chain will get its own special processing. Let's start it with another equalizer that again uses a high-pass filter. And now, the special part. Currently, when I play the break with the reverb is hearable at all times. I would like to make it quiet whenever the dry break plays, as if I used a sidechain compression on the reverb. This will make the reverb more transparent and it will fit into the track better. Instead of a sidechain compression though, we will use an envelope follower. What does it do is that it takes a waveform of an input signal, in our case an input is a dry break sound, and treats it as a modulation curve that is applied to anything we can use the map button on. I want to modulate the volume of the reverb, so in the reverb chain I add a utility, and now I use the map button to map the modulation to the gain knob. The numbers near the map button set the modulation range. By setting the range like that, I will make the reverb quiet whenever the dry break plays. This modulation isn't very audible now, but I can amplify it with the gain knob here. In the end, I adjust the volume of both break and its reverb with the last utility, and the drum break is finished.